Welcome. Here we're going to look at a useful tool called a Venn diagram for visually displaying the relationship between events. So Venn diagrams were an idea developed by a mathematician, John Venn. So what we do is we use circles to represent events, and these circles are enclosed in a rectangle. So let's take a look. The Venn diagram illustrates club memberships of students in Miss Bell's class. So let me look at the circle, this event. So the Glee Club circle. So these are my students in the Glee Club. Rachel, Michael, and Eric are in the Glee Club. I'll just put a 3 outside for those 3 students. So Michael and Eric, 2 students there. Rachel, 1 student there. So 3 students in the Glee Club. And then I have another event here, students in the chess club. So we've got Michael and Eric, they're in the chess club as well as the Glee Club. And then I have 4 students here, Brian, Lena, Milan, and Susan are in the chess club, but they're not part of the Glee Club. So in the chess club, we've got 6 students there. And then outside those circles, Ashley here is in neither club. And then we'll start writing some numbers over here. All right, so how many students are in Miss Bell's class? So 1, 2, 3, 4, 5, 6, 7, 8 in total. And I often write that outside the Venn diagram, N for number of, so 8 students in total. And then how many students are in the Glee Club? So Rachel, Michael, and Eric, there are 3. And then how many in the chess club? 6. All right, and then we get to intersections. So how many students are in the Glee Club and the chess club? So remember, and means outcomes common to both sets. So that would be Michael and Eric. They're part of both clubs. So 2 students are part of both. So that's your and. And then union is our or. So union, how many students are in the Glee Club or the chess club or both? So or means combine the groups. So if I was inviting students to a party and everybody in the Glee Club is invited, along with everybody that's in the chess club is invited, how many students are we inviting? And we're going to take a look at 2 methods for doing this. So first I'm going to look at totals. So if I take all the Glee Club students, there were 3, plus all the chess club students, there were 6. But if I add 3 plus 6, already there's a problem because 3 plus 6 is 9, and there's only 8 students in the class. All right, so what's happening is that the 3 includes Michael and Eric, right? 1, 2, 3. But when I add 6 to that, I'm including Michael and Eric again as part of the 6. So by adding 3 and 6 together, I'm counting Michael and Eric twice. We call that double counting them. And there's just 2 of them. So if I add those, it's fine as long as I remember to subtract this intersection, these 2 students. So that will drop us down to the correct answer of 7. So I took total Glee Club plus total chess club, and I made sure to subtract the 2 students that were counted in both groups. All right, there's another way to get the answer though for union, combine the groups, and that's just to look inside the circle and take all the students that are in one club or the other or both. So I could have just added 1 plus 2 plus 4, and that is 7. So sometimes one method is preferable over the other, and that first method we'll actually return to when we start learning some more probability rules coming up. But for now, let's move on. So I'm going to just redraw that rectangle now with our 8 students. So our Venn diagram has our 8 students. I'm just going to put a G for Glee Club and a C for Chess Club. And then when we start building our own Venn diagrams, we generally will start at the intersection and work our way out. So I had 2 students in the intersection. Instead of writing their names, I'm just going to draw 2 dots there. That was Michael and Eric. And then I had 1 more student there who was in the Glee Club, but not part of the chess club. So that's where we got our 3. And then to fill out the chess club circle, I had 4 more students out here. I just like my dots to visualize it. There's my 4. So in the chess club circle, we had 6 students all together. And then I had that 1 student out here, Ashley, I think. So 1, 2, 3, 4, 5, 6, 7, 8 dots, 8 students, 3 in the Glee Club and 3 dots in the chess club circle. All right, complement. So complement is read not. So how many students are not in the Glee Club? So the complement means all members that are not part of this event. So visually, if you look at your Glee Club, it's everybody not inside that circle. So that would be 4 plus 1. So 5 students are not in the Glee Club. And another way we could have gotten that answer is to say there's 8 students. So if I take away 3 Glee Club students, that leaves me with 5 that are not. So different ways to arrive at a final answer. But that's the idea of complement. So every outcome not part of the event. All right, and then G, how many students are not in both the Glee Club and the chess club? So the 2 students here are in both clubs. I'll just write the word both. These guys, I think it was Michael and Eric. Michael and Eric there, these 2 are in both clubs. So how many are not in both? It would be everybody except these 2 students. So 8 students minus those 2 would be 6. Or you can also just add up everybody not in the intersection, 4, 5, 6. And then finally, how many students are in neither the Glee Club nor the chess club? So that would just be our 1 student out here who's not in either club. Okay, so at the bottom, we're going to do some shading and introduce symbols for intersection and union that you may or may not have seen before. So we'll start here with intersection. So we'll read this as and. So events B and C. So event B and C would be all the outcomes that are in both of those events. So circle B, circle C, and we're going to shade the intersection. So those outcomes that are common to both groups. And there's our intersection symbol. So that is read and. Union, this is our union symbol. So it's read B or C. So for that event, we'd include outcomes that are in B along with the outcomes in C. So union is the combining or the joining of the groups. So shading wise, we would take all of the outcomes that are inside circle B, and we would also include all the outcomes that are inside circle C. And in this process, it includes those that are in both as well. So union, joining the groups, putting them all together. Intersection is just the overlap. And then complement, our notation for saying not in circle B, not event B, will be B with a bar over it. There's other notation for it, but we'll be using this. So B with a bar over it is read complement of B or not in B. So shading wise, this would be every outcome that is outside of circle B. All right. And I'm just going to try to make circle B more solidly seen there. So there's circle B. So everything outside that circle, not B. And then just to end here, I'm just going to make a note. The reason there's an S there as we head back to probability the sample space is what we're representing inside of our rectangle. So if I were to start picking students at random from Miss Bell's class, we could call that then all the students the sample space, and then head back to answering some probability questions. All right, so that is a start, and we'll see more Venn diagrams coming up.